Hello, college biology students. Today we are going to start electronegativity and bonding, and we're just going to have a little introduction about electronegativity. So let's begin. Electronegativity is defined as an atom's affinity for electrons. And affinity is a fancy word that means, in regular language, it means how much you like something. If you have a high affinity for something, you like it a lot. And if you have a low affinity for something or no affinity for something, you do not like it. But that's not very helpful in a chemistry context. So in chemistry, affinity means the ability to pull and hold. And in this case, electronegativity is referring to electrons. So altogether, electronegativity is an atom's ability to pull and hold electrons. And there are two factors in an atom that contribute to an atom's electronegativity. The first has to do straight up with electromagnetism. The number of protons that the nucleus of that atom has is contributing an electromagnetic pull to electrons. So the more protons an atom has, the more electronegativity an atom has. But there's also a catch. There's a second factor in atoms that contributes to electronegativity. And so we ask ourselves, well, what's going to hurt this ability to pull electrons? What's going to hurt the electromagnetic pull? Well, electromagnetism is weakened by distance. So when we're looking at an atom, we actually count distance by the number of electron shells. Francium on the periodic table is the table with the lowest electronegativity, and it has the lowest electronegativity because it has 1, 2, 3, 4, 5, 6, 7. It has 7 electron shells, which is the highest number of electron shells on the periodic table. So these 87 protons in francium have to pull across 7 electron shells, and that's a real problem. Now, the atom on the periodic table with the highest electronegativity is fluorine, and that's because it's got 9 protons and they only have to pull against 2 electron shells. So they're pulling through a lower distance. Then you may say that 87 protons has got to be a lot stronger than 9, but you're discounting the power of distance. Electromagnetism really significantly weakens with distance, so distance is kind of a more powerful player than individual protons. So some atoms have a high electronegativity and are really good at taking electrons. Some atoms have a low electronegativity and are not so good at taking electrons. But we don't care about all the electrons on the periodic table. We just care about a few. And we're going to define electronegativity in 3 categories. Instead of trying to keep track of every single atom's individual electronegativity, we're going to sort them in 3 ways. We're going to say they're high electronegative elements, there are moderate electronegative elements, and there are low electronegative elements. The low electronegative elements are going to be pretty easy for us because we're just going to say all metals have a low electronegativity. And we're not going to get too much more involved than that because we don't actually care about individual metals because this is a molecular biology course and we're going to stick to the 6 elements of life. So we're just going to say all metals have a low electronegativity. For the elements of life, oxygen and nitrogen are the 2 with the highest electronegativity. So oxygen and nitrogen, we're going to say have a high electronegativity. And then the other 4, hydrogen, carbon, phosphorus, and sulfur, we're going to say they tie with a moderate electronegativity. Now, why do we care about electronegativity? Well, electronegativity explains all bonding. How atoms come together to make molecules depends on the electronegativity of those atoms. What a high electronegative atom does when it's with another high electronegative atom is different than what a high electronegative atom does when it's with a moderate electronegative atom, which is different than what a high electronegative atom does when it's with a low electronegative atom. So if we're going to explain these connections, we have to know how electronegativity influences these connections, which is what the remaining of this unit is going to be about. With that, let's review our introduction of electronegativity. Electronegativity is an atom's affinity for electrons or their ability to pull and hold electrons. Having a high electronegativity indicates having a strong pull on electrons. There are 2 factors in an atom that determine electronegativity. 1, the number of protons in the atom, which contribute to electronegativity because protons attract the oppositely charged electrons. And 2, the distance between the nucleus and new electrons, which is counted by the number of electron shells in the atom's electron cloud. When comparing the elements, oxygen and nitrogen have a high electronegativity. Hydrogen, carbon, sulfur, and phosphorus have a moderate electronegativity, and metals have a low electronegativity. And we're bothering with all of this because electronegativity explains all bonding. How atoms interact with each other depends on their electronegativities. I hope this helps. Struggle well.